Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to do Lewis structures for multi-atom molecules. Now, if you want, you can check out my Lewis structures for diatomic molecules here, but let's start shuffling some electrons. Before you start drawing Lewis structures, make sure that you are confident in counting up valence electrons. So at this point, you should be able to just look at the periodic table and know how many valence electrons an atom has. I will not have a periodic table on my screen. You may want to have one in front of you just to reference it. This way, it's clear where all of my numbers are coming from. Okay, but before we actually start drawing or counting up valence electrons, let's go over our basic rules for Lewis structures. Okay, so the first thing that we are going to do is we are going to count up all of the valence electrons. Once we have that number, we are going to sketch out an arrangement of the atoms. Now, this is usually my best guess as to how atoms are arranged. And a hint that is very useful to me is usually when a molecular formula is written out, the first atom is very often the central atom. Another thing you can look at is how many of each atom you have. If you only have one of a certain atom, it is probably the central atom. Our third rule is that we're going to start with just sharing one pair of electrons between atoms. And if we need to modify that later on, we will modify that later on. Okay, are y'all ready for your first molecule? Let's start with ammonia. This is the molecular formula for ammonia. So again, the first thing we're going to do is we're going to add up all the valence electrons. Okay, so nitrogen gives us 5 valence electrons. We have 3 hydrogens. They each give us 1 valence electron. So I have 3 ones there. So in total, I have 8 valence electrons. These electrons are pulled together and then shared among the atoms. Okay, so I have my valence electrons. Step 2 is I'm going to sketch out an arrangement of the atoms. So I'm going to do my best guess. So when I'm looking at the molecular formula for ammonia, I see that, first of all, nitrogen's written first. There's my first hint that it's probably the central atom. Also, it is single, it is alone. There's only one nitrogen atom, and I have 3 hydrogen atoms. So I am going to say that nitrogen is the central atom, and that must mean that the hydrogens are around it. Okay, on to step 3. I'm going to start by sharing one pair of electrons between atoms. So I'm going to put a pair of electrons here, a pair of electrons here, a pair of electrons here. Now I'm going to count up how many electrons I have used. I have used 2 here, 4, I've used a total of 6 electrons, but I have 8. I can't just drop those 2 electrons. So I'm going to put a pair of electrons here around the nitrogen. Okay, now I need to check and see if this is a valid Lewis structure. So I'm going to switch colors here. I'm going to go to my green. And I need to make sure that all octets are satisfied. So I'm going to go with the nitrogen first. If I look at the number of electrons around this nitrogen, I see I have 2, 4, 6, 8 electrons. So nitrogen's octet is satisfied. If I look at this hydrogen here, I have 2 valence electrons. Now remember, for hydrogen and for helium, when they have 2 valence electrons, they have a full outer shell, and we consider that a satisfied octet. So each of the atoms in this Lewis structure now has a full outer shell. This is a valid Lewis structure. Let's draw it without all these circles. Let's draw it a little neater. The nitrogen is in the center, and it shares a pair of electrons with each of the hydrogen atoms, and one pair of electrons is what we call a lone pair because it is not bonded to anything. Next, let's take a look at water. Good old H2O. Let's start by counting up valence electrons. I have 2 hydrogen atoms. They each have 1 valence electron. plus oxygen has 6 valence electrons. So once again, I have 8 valence electrons. Okay, this is a case where the central atom is not written first. And the way I know that is because I have 2 hydrogen atoms there, whereas oxygen is just a single atom. So I'm going to put oxygen in the center. So oxygen in the center, I'm going to put each hydrogen on either side. Okay, now I'm going to share a pair of electrons. So I have 1, 2, 3, 4. I've used 4 electrons. Again, I have 8, so I have 4 more. 5, 6, 7, 8. Okay, I think this is correct, but let's double check. Oxygen is here. Yes, it has 2, 4, 6, 8 valence electrons. It has a full outer shell. Hydrogen here with 2, yes, hydrogen satisfied. And this hydrogen also with 2 electrons also has a full shell. Okay, this looks pretty good. Let's write it out a little neater. Oxygen, it is sharing 1 pair of electrons with each of its hydrogens, and it has 2 lone pairs. Our last Lewis structure that we're going to take a look at is for methane, CH4. Let's add up valence electrons. Okay, carbon gives me 4, plus I have 4 hydrogens. They each have 1 electron. Again, I have 8 valence electrons. You can see I got tired of writing all the ones out, so I'm going to use a little multiplication here. Of course, you can always write the ones out. You'll get the same answer. Again, carbon is written first. It is a single atom, so I'm going to put it in the center. So I'm going to put carbon in the center, and I need 4 hydrogen atoms on the outside. All right, let's place electrons in. 1, 2, 3, 4, 5, 6, 7, 8. Okay, looks good, but let's draw our circles just to make sure everybody has a full outer shell. Carbon here, 2, 4, 6, 8 valence electrons, great. Hydrogen with 2, hydrogen with 2, another hydrogen with 2, and my last one, yes, also with 2 valence electrons, they have full outer shells. This is a valid Lewis structure. Let's rewrite it a little bit neater. So we will have carbon, and it is going to share a pair of electrons with each of the 4 hydrogens around it. This electron needs a little help there. Okay, now you will very quickly get tired of drawing in all of these electrons. So another way that we can draw methane is with lines instead of with dots. So I have the carbon in the center, and that line is going to represent 1 pair of electrons, which also represents a single bond. So if you have 1 pair of electrons that is a bond, you can use a straight line to denote that. Now, I do want to point out that you cannot use a line for lone pairs. So let's go back to our structure for water here. We can certainly use the line to denote a single bond between oxygen and each hydrogen. However, you cannot draw lines like this to represent the lone pairs. No, 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 no. Let me erase those. Let's go back to our pen. For a lone pair, you must write in the 2 dots signifying a pair of lone electrons. So if I go to my ammonia up here at the top, the first structure we did, I can rewrite it with nitrogen singly bonded to each of the hydrogens and with 1 lone pair. Now, when you're placing in pairs of electrons, until you get really comfortable with Lewis structures, I suggest you stick with your dots for a while. And then the more of these you do, you'll start putting bonds in just naturally. But don't force it, don't rush yourself. Make sure you take your time and really understand where those electrons are going.
In this video, we really focused on single bonds just to get our feet wet with Lewis structures. But in our next video, we're going to see what happens when the atoms need to share more electrons. So I hope you'll join me. Thanks so much for watching.